I will give the answers of this exercise, so you may check. That should be easy numbers, 14 and 23. We had this example there. We solved this with two methods. I will take one method still, the graphic method. This is not exactly any accurate method, but this is many times easy way to check if you have made your solving correctly, or to find out some kind of approximate solution of the problem. So let's take graphic method still. Or this means that the method which we are using graphs. I will write here only for approximate solutions. So I will take the equations there. So we had the same example as those two previous there. 2x minus 3y equals 7 and 5x plus 4y equals 10. So these are the same equations again. And now first let's solve the intercept points of those lines. These are actually lines we are using here. Last time we had, unfortunately I don't have those lesson notes with me, but we had those equations of the lines there. And these two are actually lines, or some equations of some lines. So those lines will be in some orientation there. And for example, this may be for example this first line, and for example this pen may be the second line, and they are intercepting in somewhere. So the solution of the pair of equation is the coordinates of that intersection point there. So first this can be made in many ways, but I like to do this so that I am first calculating the points where these two lines are crossing the x coordinate axis or y coordinate axis. So the line, the first line, crosses the x-axis in the point where y equals 0. I will draw a picture soon, but let's take this let's assume that this pencil is x-axis and this is the y-axis, and so our line would be, for example, this pencil here. And now when I am calculating the point where this line crosses the x-axis, so in my picture it would be somewhere here, and when it crosses the x-axis, that means that the y-coordinate of that point must be 0, because this is y-axis, and when we are in this horizontal line there always the y coordinates are 0. So when we have this equation of the line here, we may solve the point where that crosses the x-axis by substituting y with the value of 0. So very easy to do that. Very easy way to do that is to just take away this part here. So I will put my thumb there. So I have equation 2x equals 7. 2x equals 7, or x equals 7 divided by 2. That means x equals 3.5. And it crosses the y-axis in the point where x equals 0. When we are moving along the y-axis or this vertical axis, so here we have this coordinate axis again, and when we are moving in this coordinate axis, y-axis, always the x-coordinates are 0. So in this point we may solve the point so that we are taking x away from this equation. So I am deleting this 2x, so that leaves me an equation minus 3y equals 7. Or when we solve this, y equals 7 divided by minus 3. And I will take some kind of approximate value of that. It is minus 3.333, etc. I will do the calculations first in this paper, because I need, when I am drawing the picture, I need this grid paper, so I will first calculate the points I am drawing in the big picture. So here we found the points where this first line crosses the axis, in the point where x equals 0.5 and the point where y equals minus 2.3 about. And the same with the line 5x plus 4y equals 10. Crosses the x-axis. I will leave the last part of the sentence away. We do the same. We are solving the x-axis, the point where it is crossing the x-axis. There y must be 0. So we will take the y away, and we get the equation 5x equals 10, or x equals 10 divided by 5. That means 2, simple number. So that line, I will draw the box there so it is easier to understand what I'm calculating there. So this line crosses the x-axis in the place where x-coordinate is 2, and it crosses the y-axis in the place where x-coordinate is 0, and that leaves us an equation where we take away this x part there, and that leaves only this simple equation, 4y equals 10. So y equals 10 divided by 4, or 2.5. So after this we may draw the picture. Hanging me with these cables here. Unfortunately I don't have, or do I have? Yes, I do. I thought I forgot this helpful ruler here. So I am drawing the picture or the graph. Let's see what are the maximum and minimum values. X values are between 0 and 3.5 and Y values -2 plus 2.5. I will draw the picture so that I have this grid paper here. I will draw so that the two squares are always one unit. So I will draw the y-axis there, and let's put here x-axis, so here is y and x, and as I told, this will be two grids there, or two squares there, equals one unit. So this is 1, this is 2, this is 3. Same here, 1, 2. And the first point, or the first line, it crosses the x-axis in the place of x equals 3.5. So that must be this point here, 3.5 here. This is one point of that line, 3.5 there. And the y-axis intersection point is in the height of -2.33. So we need those negative values also here. -1, -2, -3. So the -2.33 is about, it is 1/3 of the two boxes there. It is about here, -2.3. So the line goes about here. This is the first line. 2x plus, oh sorry, minus 3y equals 7. And then the other line there. We had those crossing points there, x equals 2 and y equals 2.5. Let's take another color. Maybe green is good. X equals 2, so it is here, the point, and the other one is y equals 2.5, so it is here, this point. So the line would be somewhere here. So this is the line 5 x plus 4y equals 10. And now we see that those lines actually cross each other. They have common point, only one common point, or the point which belongs to the both lines. It is here. And when we try to approximate the coordinates of that point here, I will call this point P. And now on the picture I am trying to approximate those coordinates. This x coordinates is, in my picture, it is approximately 2.5, maybe a little bit more, maybe not necessarily 2.6, but I think between 2.5 and 2.6. And when we compare that to the answer we got by solving that pair of equations, we got 2.52 or 2.52. So in this picture it shows the value of x quite nicely. And let's x equals about 2.5. This is approximate sign, not equal sign. And y equals about, it is not so easy to see from the picture, but this is -1, so it is between -half and -1. And maybe if you divide this 1 unit to the 3 parts, so probably this is about two-thirds of the 1 unit. So that would be maybe about 0.6 or 0.7. Let's put 0.6 here. And it was hard to decide if oh, sorry, it is minus. It is in the below of the horizontal axis, so it is minus. Sorry about that. Minus 0.6. It was hard to decide whether I will choose 0.6 or 0.7, and when I see the exact result, it was quite nicely between 0.6 and 0.7, so minus 0.665 was the exact value. So from this graphic method we can see that we may solve those systems of or pair of equations quite not exactly, but to get some kind of approximate vision of the correct solution. We may find out by you drawing a graph of those lines. I think we can be quite happy to get so exact answers. In older days, when we did not have any kind of calculators, I'm not that old, but almost. In those days when we did not have any kind of calculators, this graphic method was quite useful, because it was a quite quick way to solve, especially when you had a big papers and or millimeter papers, you could draw very exact drawings or draw graphs. This grid paper is not so exact because it is so hard to draw exact raw graphs of those lines. But we can be happy now. Then I will continue with a system of 3 equations. put the date here so I don't forget the order of my notes. Let's take system of 3 equations. And in this I will use the similar method as in this grammar rule. And actually I will use the grammar rule, but the determinant there is not as simple as we had in the case when we had the pair of equation. Because in the pair of equation we had 2 equations and 2 unknowns. So that makes us determinant which has 2 rows and 2 columns. So totally 4 numbers there. But when we have 3 equations, then we have also 3 unknowns. So it is quite easy to understand if I will give here, for example, zeta, the third letter there, then we will have 3 unknowns and we will have 3 equations, and that gives us 3 times 3, 9 numbers in the place of this where we had only 4 numbers. So these determinants will be 3 rows and 3 columns, totally 9 numbers in determinant. And we can't use this method by when we calculate the value of determinant. We have to use another. And let's take an example. I will try to find an equation where I will just guess the values of the equation. It takes a little bit time. I try to make equation in which we have a very simple solution, or the values of the solution are whole numbers. So I will take the first equation so that we have 2x plus 7y minus 10 zeta equals 49. Minus x plus 6y plus 5 zeta equals 61. And then I will take the third equation and do it so. For y, so there is no x in this last equation, plus zeta equals 38. So these are our equations. And we will use also grammar method in this. Of course we could solve this by, for example, so that we could solve this third letter there from the last equation. Zeta equals 38 minus 4y. So solve this letter here. This will go there. And we get the expression here, and we may substitute the zetas here in the first 2 equations. So that leaves us 2 unknowns. And when we have 2 unknowns and 2 equations, we can solve it within exactly the same method that we used earlier. but I'm not going to do that because that makes us also something like this and even worse, because there are more equations and more not so simple steps when we are solving that problem. So I will use the grammar rule here. Grammar rule for 3 equations. First, we are calculating the determinant d. Same method as earlier. We made this determinant here, and we just picked those numbers in front of those unknowns there, 2, -3, 5, 4, and that was the determinant d. We do the same here, but now we have to be careful. First equation is simple, because there are 2, 7 and -10. 2, 7 and -10. The next one is a little bit trickier because there is -x. Now we have to remember that this minus in front of x means that the x is multiplied by -1. So we pick -1 from that line, and 6 and 5. Note. And then in the last row we don't have x's at all there. So that means in that third equation the x part is 0 times x. So in front of x there is 0. That makes that x is eliminated totally from that last equation. So this must be 0. This is also something to note. And then we have 4, and zeta in front of zeta is nothing, so it must be 1, and it is +1 because +1 times zeta is 1, so that leaves only 1 there. And this is a determinant of 3 rows. I will use those determinant lines there. Of 3 rows. Or you could also say of a determinant of order 3. In Finnish we call this kolmerivinen determinantti. 3, kolmirivinen, actually we say it kolmirivinen, even though this number is actually kolme, but in this word it is kolmirivinen. Well, that is not wrong to say kolmerivinen at all. It is okay also, but mostly we are using kolmirivinen word there. I'm trying to find that again. Here you can see kolmirivinen. Kolmi. Well, here is a way to calculate the value of that determinant. This is not useful at all. This is way too to calculate it with this method, and I don't like this method either. I will use another way to solve the value of the determinant of 3 rows, and it is called the rule of Saru. I think this was some kind, probably it was French mathematician. I don't remember correctly, but rule of Saru. In Finnish we call it Sarun sääntö. And this is quite easy to solve the value of determinant when we use this rule of Saru. It goes like this. We are taking the first 3 row again here. I will write it here. 2, 7, minus 10, minus 1, 6, 5, 0, 4, 1. And then I copy these first 2 lines to here. So I will write again these numbers. 2, 7, minus 10, and the second row also minus 1, 6, 5. So these numbers here are from this system of equations of the left hand side, and these 2 lines in the bottom of this rule of Saru are just simply copied from the first 2 lines or first 2 rows there to here. And here we have a little bit similar method as we used when we solved the value of this determinant of 2 rows. We multiply these, or take the product of these and product of these and subtract them from each other. Well, now we will use this method. We will get the product of, do I have any red color which works? Because I want to try to use red many times means positive and minus means negative, so I will try to use red color here. So we will do multiplication of these numbers. So we will go in this direction here, so it means this direction here, and we are multiplying these with each other. So we are getting 2 times 6 times 1. And then we continue. We had this line here. We will move 1 step downwards, so this. And now we will multiply these. So we get plus minus 1 times 4 times minus 10. And here we have also a line which we may multiply. So we will multiply these. Plus 0 times 7 times 5. Well, actually this product will be 0 because there is 0 there. So it is always good when you have zeros in the determinant because it helps you in your calculations. You don't need to multiply all numbers because you see that the value will be 0. So this is the positive direction as we had here. Here we had only 1 positive multiplication, 2 times 4 or 3 times 4. Then we add this minus there. So we multiplied these numbers here and change the sign of that product. So we got minus 15 and this minus changed to sign. So we got plus 15 there. So in this case we are doing the same, but we are changing the direction now. I took blue pen now, and now we are multiplying in this direction. These are the minus direction. So I will multiply these, and I will use minus there. So this comes from the direction, it is minus direction, and I will get minus 10 times 6 times 0. So again we get 0 there. So we don't necessarily need to calculate the value of this because we know that it will be 0. And then this another direction here, we get 5, 4 and 2, and it is minus direction, so we will get minus here. 5 times 4 times 2. And the last one is this multiplication here. This will be multiplied. It is also minus direction, so we will get minus 1 times 4, sorry, 7. 7 times minus 1. So what will we get? This will give us 12. This will give us 40, and there are 2 minus signs, so it will be positive number. It is plus 40. Then we have this 0 there, and another 0, and the 5 times 2 is 10, 40, and minus sign, minus 40. And then the last one, plus 7. So actually this will give us 19. And this number will be the value in the nominator in all unknowns. X, Y and Z all have this number below the line. The same as we had here. We had this example here, and we calculated the value of D, and this 23 came here and here, and they were both below the line. This will be, in this case, 19. And now we will do the same as we did here. We had this dx here, and how did we get this determinant there? We used the method that we used this d determinant, which came from these numbers in front of those unknowns there, and we will change the numbers which were in front of x's to the number and substitute them with the numbers 7 and 10, or the numbers in the other side of the equation. So we took these away and substitute them with these. And here we are doing the same, or using the same method. We are changing or calculating the value of d. Sorry, I forgot to draw that d equals the 19. Here we noted had the notation of the d here, so we calculate the value of d there. And now we are finding the value of dx, and again we had the original determinant is this determinant here, and we take this here and copy there, but change the numbers here to the numbers here. So these will be in place of these. So I will have 49, 61, 38, and the other part of the determinant is the same. And now I am using also the Saru rules for calculating the value for this dx. So I will copy these values here. I will draw them here. And again, first positive direction. These will be multiplied. We will get, I will use the color logic there. 49 times 1 times 1 plus 61 times 4 times minus 10 plus 38 times 7 times 5. Those were the products of this positive direction. And then we have the negative direction. These numbers here, these numbers here, and these numbers here. Minus 10 times 6 times 38. These are quite big numbers there. I will I won't try to multiply those in my head. I will use my calculator soon, but I will write the numbers first in, or the products first in this paper. So the next row, this will be minus 5 times 4 times 49 minus 1 times 7 times 61. So this is very mechanical way to solve the determinant, the value of determinant. And now I will count the value of this, or my calculator will find out the value of that multiplication monster. So the dx will be 57. So, as we had in this earlier example, we had this x, and we got the value of x by dividing dx by d. And right now we know the value of dx, and we know the value of d, so the x will be dx divided by d, or 57 divided by 19. And of course you would multiply that in your head, but when I use the calculator I get the value of 3 there. So x equals 3. As I told earlier, when I picked the formulas there, I chose the numbers in this equation so that I will get very easy answers to the result. So this is x now. And I will then calculate the value of dy, and again we will use the same method. We have this determinant d from the left hand side of the equation, and we will substitute the column in which we had the numbers in front of y's. So we will substitute these numbers with these numbers, so these will be in the place of that. Let's see the earlier determinant. So there, the first and third column will be the same. We have 2, minus 1, 0, and the third column is minus 10, 5, and 1, and the second column will be these numbers here. So the determinant dy is this kind of determinant, and again we will copy these two first rows in below the determinant. So we will have this kind of determinant there. I will leave for the exercise you to calculate the value of dy, but I will draw the determinant or write the determinant d zeta here. So we will take that next. And now we are having the determinant d here, and now when we are solving the zeta or d zeta determinant d zeta, we will take this number from the right hand side and put them in the place of these numbers here. So in the place of the numbers in front of these zeta letters there. So it will be first two columns of this determinant will be the same, but the third one will be changed. So we have 2, minus 1, 0, 7, 6, 4, and then the last one are the numbers in the right hand side of the equation. And again copy the first two rows. No. I will make an assignment quite soon where you have to use these or solve those pair of equations or system of equations with the Kramer rule. So this method should be used. How do I write now? also calculate the value of d zeta and value of zeta. I did have one example, but I don't find it anywhere. Unfortunately, I don't find. I had one example still to go through today, but I can't find that. I'm not going to remember that. Sorry about this. I think I will that next time. I think you have this exercise here to solve. I think you probably solved this already. I will give you some exercises still to solve by using different methods. For example, this method we used earlier. So this method where we solve the x from the first equation, and from the second equation, and then solve the pair of equation with the help of that method. And then we had this grammar rule method and this graphic method. This graphic method is only possible to use when we have only pair of equations. This is not possible to use when we have three equations, or it is possible, but you had to draw a picture which is three-dimensional, and that doesn't help you to solve that problem. So we don't take that at all. I will try to find problems in which are some kind of applications of the pair of equations and system of three equations, but I will give them to you later. First I need you to practice, or want you to practice to solving these simple given equations, and these applications are mostly that kind of applications that you first have to create those equations, but that will take so much time that I will not take those today. I will leave that to next session. I think we have next week, the next time we meet. But today I think we end this. I will stay here till the clock 15 o'clock, but you may send me your assignments or ask if you need help. So I will be here available to the at least to the 15 o'clock. So I will leave you to time to practice this now and try to solve these problems which I gave you. This exercise here solved by different methods, and then this system of 3 equations by using the Saru rule when determining the value of these determinants. So I will end my speaking now and my recording, and the time we are having left we will use for practicing. Thank you for today again.